And let's go ahead and build a transfer function and solve a problem here, right? Let's go mass positive to the right, ft, right? Oh, mistake in the notes. Okay, so mx double dot the function of t plus cx as a function of t plus kx as a function of t is equal to f as a function of t, right? And we're just putting the t here because we're also dealing with the omega in the same chapter. So that's why we added the t back. The frequency response function, we know, right? So this is the same as every other one. We don't need to solve it again, but we can if you want. It's hj omega is equal to 1 over, anyone remember it, k m omega squared plus c omega j. That sound familiar? And then, well, the amplitude response, h of omega, right, is equal to the absolute value of hj omega equal to 1 over square root of k minus m omega squared plus c squared omega squared. Applying the equation that relates, so if we take our equation applying that Sx of x is equal to h j omega absolute value squared s f of f, right? We get that s x of x of omega is equal to 1 over square root, oh, sorry, nope, 1 over k minus m omega squared plus c omega j squared s f f of omega. That makes sense? Do you guys see where this came from? Just replacing terms. All right. So what is our SFF of omega? Right. So actually, I guess so let's say that the system is, generated with white noise, right? So the system is subjected to white noise. So what's our input? The spectrum, maybe? Yes. So the purple one? How are we going to put that in? I mean, that's right. I mean, that's definitely our input, right? This purple one, or something like it. But is that easy to use? No. Yeah, so what do we do? Yeah, so we'll just use S naught, right? So S naught becomes something that we can deal with. Because it's white noise, we have SFF of omega is equal to S naught. Right? Additionally, we can break apart our absolute valued squared symbol, right? So a little bit of take the square, you know, find your common denominators, add things up. You end up with S, let's move that to the left, Sxx of omega is equal to the absolute value of hj omega squared S naught, which is equal to 1 over k minus m omega squared plus c squared omega squared, right, times S naught. But I can just go ahead and throw that S naught up on top, like that. Right, so let's go ahead and see what using various So let's go ahead and pull this in. Right, and so here's our frequency response for various different spectrums. Right? So kind of just picking different parameters here. K equals 10, M equals 10, C equals 10, and zeta. Right? And we can kind of adjust things here. You can see the different frequency responses, right? So for for some of these, right, you have S naught K squared. I guess the K changes, right? Yeah, the K changes. So you have S naught over K squared is your offset here at the base. And then you can see how they respond to different frequency responses. Pretty cool, right? And again, this is just kind of, you know, looking at the answer here from a white noise perspective.